Finally, we have a double integral problem where we're given a double integral and we're asked to switch the order. It's given as a dx dy, and we're asked to write it out as a dy dx. The reason for this typically is that the integral is hard to do in x first for some reason, and we want to switch it and see if it might be easier to do y first. And we'll see examples of that in some of our homework problems and in our in-class activities. The trick is to be able to get a good picture of what's going on. So let's try to illustrate what is our region of integration here. So I'm going to draw the xy plane, and I'm going to think about what's going on. X first means I'm going from x equals 0 on the left, when I look at this endpoint of integration, up to x equals the square root of y on the right. That function, I'm more familiar with it written as y equals x squared. And if I write it like that, I know what I'm dealing with. It's a parabola. So I'm going to draw that parabola, y equals x squared, or x equals the square root of y. I have some rectangle where I'm going from x equals 0, which is the y-axis on the left, over to x equals the square root of y on the right. And so that's my picture. And then in y, we're going from 0 up to 9. So here's the height, y equals 9. And that gives us our region of integration. We now have a sense of what it is we're trying to integrate over. This point right here would be 3, 9. If I need to, I just plug 9 in for y and solve and get x equals 3. So that's my region. Now with a good picture of the region, I can figure out what my integral would be in a different direction. So let's change colors and do a different direction here. With that direction, I want to be thinking y is going from what down below to what up above. Now y down here is going from y equals x squared down below up to y equals 9 up above. And then I have my x e to the y dy. And that leaves for x, if I'm going to do a series of these vertical rectangles, the very first one starts at x equals 0, and the very last one ends at x equals 3. So now we have our double integral written out as a dy dx integral instead of the given dx dy. And that's how we switch the order of integration. It relies heavily on being able to come up with the picture and always thinking x on the left to x on the right, or y down below to y up above.